Hi, everyone. In as a continuation of the chapter 5, we in this session we will introduce the sampling with and without replacement. We have a small difference between them, but the result is is clearly influenced by the outcome occurred in the first event. Okay, and the first stage, if a outcome occurred, so with replacement, so we replace it, then the outcomes are the same in the second stage. But without replacement, normally the outcome occurred in the first stage, okay, shouldn't be replaced. So the outcomes are less without replacement in the second stage. So we will show this main difference with some numerical exercises. In the first exercise, we have a bag containing 3 red discs and a green disc. A disc is selected at random, its colors noted, and the disc replaced. So normally in the first disc, it could be red or red or red or green. But replaced, so normally we have again in the bag, we have again 3 red discs and 1 green. So the second disc could be red, 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 and green again, and red, 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 and green again, red, 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 green again, because each one here is replaced before in the back before going through the second selection. Though the sample space are given with these branchings, for example, RR, 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 RG, and so on. So normally if we have a 4, 4, 4, 4, we have as a whole, the total number of possible outcomes is 16. Okay. So we are interested in the number of outcomes with different colors. So normally R are same color, same color, same color, different color. The first one, same color, same color, same different color. The second one, same color, same color, same color. The second, third one, fourth one, fifth one, and sixth one. So we have a six outcomes with different colors, and we divided over by the total number of possible outcomes. Easy. In the same way, we can continue the following exercises are in the same with the same strategy, adopting the same strategy. For example, we have a ball. Here we have a red ball, 2 red and 2 black ball in the bag. So normally, if in the first ball occurred is red, so normally we replace it in the bag. So when we replace it in the back, so normally we have again the same numbers of outcome, the same number of balls and the same color. We have a 2 reds again and 2 blacks again. So normally the second ball could be the same, red or red, black or black. So normally, and similarly to the others, because each result of in the first stage, each ball in the obtained in the first stage should be replaced. Okay, the sample space here is consists of also 16, because we have 16 branches. We have a 4 plus 4 plus 4 plus 4. We have a 16 different outcomes, the possible outcomes, and they ask us about 2 red balls. So normally 2 red balls, we have a 1, we have a 2, we have a 3, we have a 4, and we have only 4 over 16. And about a red and black in that order. When they ask about the order, so we mean red, the first ball red, and the second one is black. We need only to count the RB outcomes from the possible outcomes. RB, we have a 1, 2, 3, and 4, and only RB we have a 4 from 16, and so on. So So easy. Here they ask us to count the possibility of having balls of different colors. We have so normally of different colors, RBBR, because the others are of the same colors. Okay, and so on. So normally you will notice that all these one are very similar. What about sampling without replacement? The main difference is if the first, for example, ball, disc, or any outcome on any result of the same first stage in the obtained in the first stage is not replaced, then the number of outcomes for the second stage event is one less than for the first stage event. It's very clear because we have also a bag contain 3 black discs and 1 green. So for the first disc could be black or black or black or green. Good. And if we for example, obtained black as the first disk is black, so normally is not replaced. So normally we have in the back 2 blacks remains in the black. The remaining balls or discs are 2 blacks and 1 green. So the second disc could be black, or green only. So normally instead of having 4 outcomes, if it replaced, if the first disk is replaced, so no, we will obtain 4 outcomes, but here we will obtain 3 outcomes. We mean 1 less than for the first stage event, and the same for B, but for G, for example, we have only 1 green. If we obtain the as first disk, we obtain green. So normally the remaining disks are 3 blacks. So black, or black. So normally, if we write in the right of that sample space, the all possible outcomes, the elements of the sample space are BB, BB, BG, BB, BB, BG, and so on. So normally in total we have a 3 plus a 3 plus a 3 plus 3. We have a 12 as the total number of outcomes. And the number of outcomes with different colors, not different color, same color, different color, same color, different color, same color, different color, different color, different color, different color. We have a 6 over 12, which is equivalent to 1 over 2. And also you can note that we are turning around the same idea in all these examples. For example, 2 letters are chosen one after the other from the letters of the word sum. We have a thumb, we have a CS, we have a U, we have a M. So we are interested in choosing the first one and the second one. If we choose the first one, so the first one could be S or U or M, but without replacing the first letter. If we choose S, so normally we cancel S from the bag or from our choices, and we could have only U or M. If we obtained firstly U, we will get S or M as second letter, and if we get M as the first letter, so we'll get S or U only because we are talking about a selection and sampling without replacement. So the sample space consists of 6 as a total number of possible outcomes, and then firstly they asked us that the 2 letters are the same. We can't have the same letter, the same 2 letters, congruent letters, because we know the sum consists of 3 different letters, so it is impossible to have the 2 after with sampling without replacement. So a 0, it is an impossible event, 0, so the probability of impossible event equal to 0. Okay, and you can complete also by yourself. The following exercises are very, very, very easy, and you can also read the hints to solve properly and correctly your exercises, the remaining one. Thank you for listening. Bye bye. Have